Energy transfers during braking by KayScience.com. This car is currently stationary, so it has no energy in its kinetic energy store. When it starts moving, it's going to have an energy transfer from the chemical energy store in the petrol, which is the fuel in the engine, and that's going to be transferred to the kinetic energy store of the wheels. So when the wheels start turning, the car will move. This is because there is going to be kinetic energy stored in the wheels of the car. The kinetic energy store in the wheels will increase. So for the car to slow down, what needs to happen is the brakes need to be applied to the wheels. This shows that there is some thermal energy stored in the brakes of a car. And when the brakes are applied to the wheels, as seen here, there's going to be an energy transfer from the kinetic energy store of the wheels to the thermal energy store of the brakes, and also to the surroundings. So now the brakes have been applied, there's going to be an energy transfer from the kinetic energy store of the wheels. So the kinetic energy store of the wheels will decrease. Kinetic energy store of the wheels will decrease. And this energy is going to be transferred to the brakes thermal energy store. This causes the car to slow down because the wheels have got less kinetic energy in their kinetic energy store. So the thermal energy store of the brakes are going to increase. So there's going to be more energy in the thermal energy store of the brakes. Thermal energy is also transferred to the surroundings as dissipated energy, wasted energy. This causes the car to slow down because the wheels have got less kinetic energy in their kinetic energy store. It's question time. Attempt these questions to check your understanding. This car has a mass of 500 kilograms. It is traveling at a speed of 10 meters per second. So this is the car's speed. So the car currently has energy stored in the kinetic energy store of the wheels. So we can now use this information to calculate the kinetic energy stored in the wheels. So you can now recall the equation for kinetic energy. E equals 0.5 times mass times speed squared. So now you substitute in the numbers because there's no need to rearrange. E equals 0.5 times mass, 500 kilograms, times the speed squared. So that's going to be 10 squared. So that gives you a kinetic energy stored in the wheels of the car of 25,000 joules. So we've calculated that there's 25,000 joules in the kinetic energy store of the wheels. So the car comes to a stop. This is because the brakes are applied. The brakes are applied, and that kinetic energy stored in the wheels is transferred to the thermal energy store of the brakes. So now let's calculate the new kinetic energy of the car. So the car is traveling at 0 meters per second, that's its speed, and the mass of the car is 500 kilograms. So recall the equation, E equals half mv squared, kinetic energy equals 0.5 times 500 kilograms times 0 squared. That gives you the kinetic energy stored in the wheels of 0 joules. So there is now no energy in the kinetic energy store of the wheels. This 25,000 joules was transferred to the thermal energy store of the brakes and the surroundings. So not all of the kinetic energy is going to be transferred to the thermal energy store of the brakes. Much of it is going to be dissipated to the surroundings. Press pause to answer the questions. The answers will follow. And if you're stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. Visit KayScience.com for more free videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.